In this session, I'm going to demonstrate some of my workflow techniques that I use personally in project form. And in today's episode, we're going to be making a rather pleasant looking landscape, I hope. And I'm hoping to keep these under half an hour. And with that in mind, I'm going to be brushing over a lot of the different types of tools that I use in an effort to maintain that time frame. But we can translate the amount of effort that it takes to get to the result, hopefully, that we have in the end into maybe hours or possibly even days. That obviously the techniques I'll be demonstrating will produce the kind of result that hopefully that you're looking for. So to start off, the most common build element as far as landscape goes is the standard shape of a plane object with enough iteration as to expected deformation as to whatever tools that we use to create an extrusion for our landscaping, be it mountains or a nice slopey hill. Now, as far as a build material goes, this is not very good. The reason being is that polygons are planar in nature, and that will want to be extruded from the face outwards in actually two directions, as opposed to the three that we would need for a proper deformation as to landscaping high mountains or a rolling hill. Ideally suited for hard body objects, like, say, for example, an oil drum. To get the kind of resolution out of an oil drum that we would need to make it look like an oil drum, 8 segments is not going to do it. So we'll have to kind of pump that up to 24 before it starts to look good, and then from 24 to 32 it starts to look smoother, and of course 64 would be considered high detail. So that's the kind of things that you can build with this. That unfortunately, this kind of lacks that ability to move in freedom, be able to create smoothness and definition of shape in 3 directions, simply because the amount of detail that you would have to put into it to achieve that shaping has to be increased and not necessarily decreased. So by starting, the philosophy though here is to start high and work low. The reason being is with high quality assets, we can extract from that the kind of materials or even the kind of assets that we need as to practical needs. So, for example, a million polygon player model is obviously not the kind of player model you would want to see in game, yet it is a resource as far as putting increased crevices and scratches and even scars that we can extract a normal map out of that can be projected onto a lower detailed model, a better fitting as to a particular game design or concept. But concept-wise, this is not a very good material because it is a hard body by design. What is soft body, which is what nature represents as to the nature of like hills, valleys, or whatever you want to put into it as being chaotic, is available to us though in the form of cloth. Cloth does have a soft body representation as to tessellation, as well as to the amount of density that we can apply to it that is easy to edit to the kind of desirable effect that we're looking for. So to create a cloth as part of the cloth simulation feature that's available in 3ds Max, we simply draw out a rectangle and we use a modifier that's available to us called Garment Maker, which is right down here. And as we apply that to the surface, you can obviously see that the topology is immediately different than our topology that we had with a surface that would be suitable for hard body surfaces. So right away, it's not difficult to see at all how this would perform better as a flag as compared to its hard body version in polygons at a decreased value. So if we look at the current poly count, we'll use this as kind of our scoreboard, so to speak. We have a count of 520 faces. This is not K, that's faces. So we can certainly afford to add a little bit more detail into this as to density, which is right here. We'll talk about that in just a moment. But we can probably double the overall count as to quality of resolution, and then of course when we simulate or whatever, this will deform properly as a flag at lower counts than as comparable to, say, the same flag done using polygons. Cloth is aka soft body. So since we've established that, we obviously don't have enough density here to really do anything as far as editing goes. So we kind of need to increase that density so it's actually usable as to a count, so to speak. And we need to hit a target in this case of about 50K for the purposes of this tutorial, where in most cases I'll probably run it up to about 100, as I know I can, on the back end of it, based on go high, go low, the overall resolution of this design is going to be maintained based on this type of topology. So focusing on the density value here, we got to be very careful about this because small numbers are large. So if we think in terms that if we pump in a value of 1 into this box, we're going to double our resolution of our density. That's not the case. What's going to happen is it's a factor of like 100,000. All of a sudden you're going to go from something that's 520 to basically you got to turn the computer off because it's still calculating the topology. So small values to begin with. Now, how it derives its value, its topology, is almost random in nature, and I suspect it has something to do with the overall how we defined the volume of space with the rectangle spline shape that we pulled out. Unfortunately, that never does seem to work out because you can almost make a pool, put some cash into it as to what the actual resolution will be as to our counter down here. See, 520, and as to very low values that we punch in here, say adding a 1 to the 0.01, and then we kind of wait it out to see what happens. Now, as luck would have it, we hit a little bit above our target goal. I like to be in about the 50 because that's the line between being not enough and too much for the purpose of this video, because editing this amount of geometry is kind of sluggish at that level of density. So the last thing you want to do is watch grass grow, which would be the case of me trying to pull things up and down to create the kind of definable landscape that I'm looking for. So to me, that's not really a problem. I'm okay with that. Work slowly. I usually work really slow. So unfortunately, if we did this from beginning to end, you're talking about maybe a 3-day video to actually get the kind of results that I want. But for the purpose of showing and displaying some of the tools, we'll select this, say this is done as to the need to create a material as to part of the iteration process. Now, iteration is having the ability to always being able to fall back to the last build or the last design that you're pleased with. And in most cases, the file function as to incremental progression will do the job for you. But I like to do things based on using the editing modifier stack. So most cases I'll place an edit poly on top of an edit poly, and that way I can always delete this off if anything becomes a little bit too destructive to this the element below it. So I'm happy with this as a build material, so to speak. So if I start editing this and I make a mistake that I can't back out of for some reason with Control-Z, and of course I forgot to do an iteration save, then all I have to, then I'm kind of messed up. I have to actually delete this and probably more or less start from scratch. But if we do iteration progress through edit polygon placements on our stack, we can name that. And since Mountain 1 is going to be our first iteration as far as progression goes, we'll call that MNT1. Now, normal workflow wise, it's not uncommon for me to have this stack like 12 deep as far as poly modifiers go, each defined by a name and each serving a particular purpose as I start making changes. And then when I'm sure I'm happy, then I can simply just go right click and collapse all to a single iteration as a poly modifier. But I'm not going to do that because as part of a workflow technique, it would obviously add additional time that's not necessary, but I'm just going to kind of point that out. I'm also going to point out a lot of the tool usages rather than actually demonstrating them, because if this is something that works for you, by all you should be reading the manual. That's the way it's done as far, and decide what it is you can use out of this as part of your own personal workflow that you know that works for you. What works for me might not necessarily work for you. So Soft selection is pretty common in most applications. Quick explanation is a gradient between 0 and 1, which creates the ability to deform shape in an arc. We also have access to different types of brush options and curvatures, but we won't go into that. Read up. Okay, so fall off is not high enough, so let's try 6,000. Okay, maybe 6,500. Oh, 65. Yeah. Okay. There's a bit of a bug that that it wants to tack on an extra 0 from time to time. So if that happens, spacebar, hit enter, and that correct that bug for you. Okay, so this gives us a nice little selection, and we're going to create kind of a hill. Now, as to relative scaling, just to brush over it quickly, the ideal would be able to get something into Unreal 4 as quick as possible, so you can create a consistent source chain from our build as we have it here, so we can see how it looks in reference to the first-person perspective once we're standing right in the middle of this environment and looking up. So is this actually a mountain, or is this more of a molehill? Or is this something that your kids will fly down during the winter on the toboggan? We don't know until we can look at it from that perspective. So another option is you can use what's called relative scaling, where if we know a certain size, like for example we know how big our character is and we know how big Mount Everest is in relationship to that character, say at the distance of 5 miles, then obviously we can make it correct to scale if we wish. But that's that's a little bit too deep for us to deal with right now, and we'll move on forward and create what most want to do at some point is to create an easement that would maybe represent a roadway or maybe a donkey cart trail or a pathway that may lead up to the top of the mountain. And one way to do it, of course, is using the soft selection. And I would like to kind of mention that there are modifiers under the rollout here that will actually deform surface areas as to volume of space. So you can kind of use those as cookie cutters as to creating a controlled, say a controlled edit into the surface as to directly to needs. So say for example a roadway, we can easily create that as a spline, and there are modifiers under the stack, find out by reading the manual of course, that will allow you to more or less bake that into the surface that you can then proceed from there. But we're kind of getting a little bit off the subject. So we've created a selection here with our soft selection, and we already know what happens if we pull it up. So we can kind of predict what would happen if we went planar in the Z. In other words, if we drop that surface down so it's horizontal to where it was before, and that creates kind of a cart trail or a roadway or what have you. That will then segment into our next tool usage, which I use a lot, and there's a reason why. But this also presents an opportunity to promote the idea that a selection can be used as a means of protecting a given area. So we have this roadway. We can create a selection called road, so we can always get back to it again if we need to be as we deselect. We can do a Control I that inverts our selection, and as you may know or may not know, anytime you create a selection, any type of edits that we perform as far as any other procedural type of effect down here will only affect this given area. So in this case, the one that I use a lot is the relax brush. There is a reason behind this, in that we want to keep as much as possible a normalization between 1-to-1 as to how surface is as a percentage in world space as reflected by its UV mapping counterpart. So if that's 1-to-1, then whatever texture that we put onto it is going to be clean, it's going to be stretch free, and it's going to look good, and it makes our life a lot easier. And we can accomplish that by setting our brush size to about 6,000, and we can brush in a little bit here and relax that area. So this kind of normalizes our values. It's not always a perfect 1-to-1, but it's close enough, and we know we're done is when anything that's within this volume of space of our brush stops moving. So we can keep brushing, keep brushing, keep brushing, and as you can see, as we brush along, our road stays intact, but we're creating a little bit more of an easement into it, so it's not going to cause us any grief of having to go back and rebuild it again. So things more or less stopped. I'll call that that idea as to the need for a relax consistently is rather important. Now this is something that I consistently do. Edit, relax, edit, relax, edit, relax, edit, relax. So I'm not going to be doing this obviously in this video because it would consume an amount of time, but the result is that the UV mapping usually takes care of itself pretty good, and it actually allows us to extract the low resolution model out of this much easier, which puts us into our next section as to tools, and that is push-pull. We can push-pull in either directions. Positive numbers will go out, negative numbers of course will go in. Those push-pull values can be based on a curve. The curve is actually, if we look here, is a cross section of actually how this will actually pull this information up. And we can create our own customization of that, and it will kind of try to attempt to deform based on that value. So you're going to kind of experiment with this. So you can actually create curves that creates the easements into the geometry on a one-pass go. But it takes a lot of extrude, Control Z, extrude, change value, extrude, Control Z. So you get the idea of that. To start out as a curve, I'm going to show you the bad boy here. This is a nasty little one in that it creates an obviously a linear one-to-one relationship as to deviations in the geometry. Our pull value is actually a little too low. So at a one-to-one, still too low. We need to be 10 times that. Okay, so 1,000. And if we sort of brush, this is a nasty little bit of work here. This is a severe difference in between the elevation as to planar. So down here to up here, anything in this area in here is a shear wall effect. So anything that's mapped to this can't be mapped. It's more or less, it takes it and it stretches it, and you cannot even define what kind of material it is, and it's all blurry and it looks terrible. So this is why we need to kind of relax things out consistently, so this kind of deals with this problem type of area. But we're going to leave that in as kind of as an intended mistake, and look at other curves that we have available as to deforming. And you can see that these are a little bit more slopey, but they're also additive. So we can sort of click and see the results. Click, see the results. So click, see the results. So we can quickly build up kind of a mountainous type of terrain. Obviously I'm just blasting through this, but we're getting things tubbed in. And I would say we've kind of created an attachment to this area, which now we'll talk a little bit about maybe fine-tuning. So maybe decrease the push-pull value down tremendously, and of course our brush size, 6,000 is a bit too much. 3,000 is usually a pretty good starting point. Maybe about 2,000. And we'll look at these little buttons down here. These actually will translate the normals out from the given direction as to our translate down here in the corner as we turn around. So as you can see, it gives us a world space orientation as to which direction that we're pushing. So if we want to, actually, you know, I am going to fix this problem here right now. It's bugging me. So with that being said, you can see that this area over here is inverted as to selection, and we can use the big hammer in the toolbox called the relax modifier, so the relax value. So we can correct this quickly and easily by increasing the number of iterations to get rid of that hard edge. Overall, it doesn't matter because terrain is terrain, mountains is mountains, and we want to get a nice clean base. We can talk about this for a fair amount of time, but keeping this relaxing type of effect is rather important, as you probably can tell based on how much I'm harping on it. There goes a car, truck, big one. Okay, so push value, back to that, and we'll start to sketch in detail. And this is where I'll probably get a little quiet. Okay, over here we'll decrease the brush size down to 1000 and start pushing out. More or less, I just want to kind of dump in a lot of changes in surface directions. And once again, I go push, relax, push, relax. So this area in here, I'd be going relax and obviously changing values. Okay. Habits are hard to break. Obviously, going back to what I already did. The whole idea was just to create kind of a test type of surface. So I think that kind of pushes us into an area where we have a fair amount of geometry that is pulling out from all sorts of directions. We'll do one last little relax. Well, we probably won't do one last little relax, but we don't need that much as we had before as far as iteration goes. So we'll pull that back a bit. All right. Until we see things are smooth. Now, harping, this is more important. It will save you grief, and we can always sort of twist things around. Now, normally when I use the paint deformation tool, I usually switch to my tablet, which gives me a lot more sensitivity and control, say, than the mouse would. So this thing kind of brushes on like using a paint. To kind of illustrate the negative aspect of this, of a push, of what it does, and we'll do push value here. You can see how we can sort of push into the mountain. Okay. Create a crater type of effect, and of course, once again, the relax value, go in there and relax that out. Oh, let's revert. That will revert everything back to what it was. Okay, we'll go in here and kind of relax everything. I'm just going to put few more subcomponents into it. We're not doing too bad on time. And if we wanted to, we can keep going and pushing in and actually create somewhat of a cave area if we wish. Okay. It's still moving. Okay, at this point you're probably watching grass grow, so I think we're going to call what we have adequate, although it's not adequate by me in any sense of the imagination, but it does. It's enough here to actually prove what we're going to be doing here. And if we look at throwing on a Blade Killer's fallacy famous UV mapping texture, we definitely have some really distinct outcroppings, enough to actually demonstrate and illustrate the point in this short half-hour video without actually getting into finite detailing. You know, I could spend at least 2 days doing this, and of course there'll be 3 or 4 different variations. But the mapping's not bad. Kind of a little bit pulled in. See, we were talking about how some areas of a map can kind of pull in and underneath one another, so I don't know if this would be actually a good thing or a bad thing, but it's going to be problematic, as obviously one way or the other as far as UV mapping goes. So to kind of touch on that subject a bit, excuse me, I'm just going to drop on a UV map and do a quick cheat as to layout here. Select all and do a reset peel, which then should peel this out a little bit more like somewhat like an orange would peel out. And our UV mapping should be a little bit better or superior to what we had as to overall detail. So yeah, okay, you can see that everything is kind of normalized, kind of in that one-to-one zone. We have some big areas and some small areas, so brushing on definitely a lot larger in this area. So there's going to be some inconsistency as we paint textures and material onto that in a 3D plane. Let's kind of pump things up a bit and cheat. Okay, we'll convert this over. Let's say, for example, we're happy as we can be, and we're going to convert that over, and we're going to gives us an opportunity to kind of look at what we got going down here. So, not bad, not not any kind of sub-zero type of. We have obviously a variation over here that's not pleasing, but for the most part, I'm happy. And as you can hear, it's raining. And we'll do an auto smooth to kind of clear things up. That puts our current project into what I would call a delightful state, and we can do a quick examination with a simple stone material to kind of see if there's any kind of obvious shearing effect. And it looks pretty good. This was obviously a cheat. I have about 5 or 6 different types of rock materials that I like to use to get a sense of where it's going, because we're going to be painting that on at a later. This little canyon here would be a great place to put in water coming in, and then we have waterfalls or whatever. I mean, the options are endless, but obviously we're still looking at our count over here, and we're thinking to ourselves, okay, we got a problem here as far as the amount of detail in the geometry, which is not beneficial to any kind of video game, but in my opinion, 64K big deal. So. But the boss is the boss, and he wants this lower. So we have to, first of all, take into consideration that we need to probably segment this map later on into pie shapes as to wedging the culling effect that the engine does as to detail. So, for example, if this was a 64K model in front of us, we can turn our back, and if it's not seen, then it's not rendered. And a mountain, in this case, if we see one little freckle of vertice, it renders the full thing in full. So if we cut these down into segments as units, then if we don't see it, it gets called, and that adds to the performance envelope. But where we're going to start kicking in the optimization, of course, is we're going to more or less cheat and use the Pro Optimizer, and we kind of messed up our texture, so we got to keep textures and then recalculate. And as you see the poly count there, we didn't do anything because we're at 100%. So let's do the first bump here. Let's take her down to 50 and see what happens. I didn't see anything happen. Let's turn it on, off, on, off. Okay, we dropped down by half, and there is absolutely zero resolution loss as to geometry, shape, and form. Nothing changes. The only thing that changes is you see a little bit of sparkly over here. That's not a change in shape and form. That's a change of the smoothing group information that's on this surface as 1 combines with 2 when we drop the count by half. Okay, let's take this down to 25%. Now we're at 15K. Did you see any changes? Turn it on, turn it off. I'll turn it on, turn it off. I'll just do a few times, because YouTube is actually rather bad at showing finite details like this. But I'm looking, and once again, the only thing I see is variations in smoothing groups. Let's go a bit crazier. Let's take her down to 10. Our countdown is now down to 6K. Turn it off, turn it on. Okay, we do see some movement now in as far as geometry goes, but once again, the majority of the effect is the changing of smoothing groups. We have a little bit more action down here, but it's neither good nor bad. It's indifferent. So if we look down there into our little cave, not much of a change. Okay, so if we look at the wireframe, we're too much, down to not enough. The reason we're able to maintain the overall consistency in our geometry is because we used a soft body material to define the shape and form. If this was polygons, right about now we'd be starting to get this little peak here would become a peak. It wouldn't have maintain this type of smooth translation. See, it loses some shape and form, but I wouldn't say it's good. I wouldn't say it's bad. I would just say it's different. Now let's get really crazy. Drum roll. 1. Turn it on. 5, 6, 7. Remember what we started out with? I don't. It was probably a little bit higher than that. But as far as volume of space goes, this would actually still be considered usable as far as a game asset. Although, even if it's lower in resolution. We go F3, we look at the wireframe. It's pretty darn good. But 5, 6, 7. On, off. On, off. On, off. On, off. Okay. So hopefully that translates through YouTube. So obviously we can create lower and lower density models. But I would say that let's take it down one more notch. Boom. What happens if I turn it on? Okay. I was hoping maybe for a little too much. We have a count of 3. I don't even think we can get back. Let's try 1. Let's try 10. There we go. Okay, we can get back. Okay, so anyways, we'll kind of call that done. We're a little over the 30-minute mark, but I hope that what I demonstrated here is that the idea that starting high with extremely large numbers, I mean 100K, 200K for your terrain, ultimately gets you down to 256 faces. Okay, fine and dandy. We'll end here.